Hello, my name is Alessandro Golkar. I'm an assistant professor at the Skolkovo Institute of Science and Technology, and I lead a research group there called the Strategic Innovation Research Group. I work in space system engineering, so in the field of, first studying, doing conceptual design about space systems and space missions, and coming out with novel concepts on how to utilize space for the benefit of society in general. Second focus of the work is on how to improve design practice in general, not just for space but also for other fields, and some experimental work on right now on stratospheric balloons flights, trying to fly experiments for people. Mainstream research that I'm working on now is the idea of federated satellite systems, the idea of developing cloud computing environments in space, share and utilize resources that every satellite has into a network, and that allows you to create, for example, missions, virtual missions. It allows you to repurpose your mission in case of instrument failure. It allows you eventually to create an in-space market of resources which you can use for commercial purposes, and you can make a better use of the resources of your own satellite which you already invested on. In my field, the dream that people are trying to accomplish is the idea of model-based system engineering. So the idea that someday we will not resort to documentation anymore to develop projects, but rather we will have these very articulated, sophisticated models that integrate things all together in a unified way, which will bring from phase A to production. Utopic dream is to start a model at the phase 0, so conceptual design, and evolve it to the point where you can bring it to 3D printers, print the parts that you want in different materials, assemble it, and have it operational. I think people have developed parts of this big dream. There is a growing community interested in MBSE, Model-Based System Engineering. We are very good into doing that in phase A, I would say, preliminary design, and the current focus is to extending to the next phase, phase B, detailed design. But I think there is still a lot of work to be done in the area. Document-based engineering, which is basically how people typically do things, is you have requirements documents, you have specifications, you have interface control documents, and you're assuming that all knowledge of your system is captured by those documents. And experience tells us that this is not true. So if you think, for example, at the space program in the 60s in the US, much of the knowledge has been lost, right? But they had documents. So it means that something has gone wrong. Either the documents were not good enough, or very likely, since people typically are smart and good, documentation is not probably the best way to do this. Now, model-based system engineering is one alternative way that people have been exploring since the 80s with the advent of CAD. It was the first step, right, to have a digital model of your system. And now what we're trying to do is to integrate, not just having a pretty picture, not just a CAD model, but it's also integrating this model with the thermal analysis model, with the finite element model, with your orbit simulation model, everything put together in a unified representation that ideally you can bring to the machine shop for production, right? And having a change on one field, on the orbit, automatically being reflected into the results of all the other analysis. This is model-based system engineering. Now, the problem is that while you may think that this is trivial and this is something that should happen, it does not happen. All these analyses today are separated, right? And so there are many different approaches. For example, concurrent engineering is a way to solve that issue. But as of today, we still are not able to do this end-to-end model-based system engineering. We're working on it. It's research at the moment. think at space exploration. Space exploration requires that all systems have to work with each other, right? 40, 50 years ago, we have done, one of the reasons why system engineering grew as a discipline was the Apollo program, right? Because you had all these systems that had to interface with each other. The launch vehicle with the, with the transfer module, with the descent module, the ascent module, they all have to work together in a seamless way, etc. Today, we are not able to do Apollo anymore, right? We have to rebuild the knowledge, right? And we have to redo the system engineering work for that. And as you probably know, the main challenge today of exploration, well, first challenge I would say is cost, right? So it's too expensive for the means we have. And the second challenge is we don't really know how to make people survive outside of low Earth orbit, right? We don't really have an understanding of the environment, the radiation environment. We don't really, we have some data, we have some evidence, but we don't really know how humans react to that environment, right? Are they going to survive on a trip to Mars? Probably not, as of today. And you can see this as a systems problem. So you can use systems analysis to analyze, for example, integrate what are the science discoveries on solar environment with the reaction of the human body, which is a system per se, to that environment, with the transportation system that has to have appropriate radiation protection, which has an impact, for example, on mass and cost. Right? So all of this is a big system with technical impact, societal impact, to consider policies, regulations. How much, what is the dose that an astronaut can be exposed to? That's regulation, right? So that's why I see it important. You have it in your pocket, your phone. A mobile phone today, for example, without the infrastructure that is behind, is useless, right? So a phone needs an infrastructure. The only way in which you can build, design, and manage, operate an infrastructure is by doing proper system engineering. Okay, so system engineering perhaps does not have a direct impact. I don't know. It's not like if I'm a biologist and I find the cure to some serious disease, right? So this has a direct impact to people. But my work maybe is not as direct, but the impact cannot be neglected either, because good system engineering allows the development of very complex things, which then allow you to have a better life, to have more efficient transportation, more efficient IT infrastructure, more efficient medical services, and so forth. One of the trends in our society today is interoperability of things, right? So, you can interface, I don't know, talking of IT, you snap a picture on this phone, and then you have it on your tablet, you have it on your computer, you have it everywhere automatically, right? And this is possible if and only if you manage interfaces properly, and you can manage interfaces properly only if you do system engineering, right? So what is the effect on people's life? People have a much easier life in interfacing with technology, right? People have a much more efficient way of accessing information. People have many more services that are made available to them thanks to system engineering at the end of the day. So I see impact everywhere. I would say that my field, system engineering, originated in aerospace mostly. It's expanding its scopes and interest into, for example, energy, automotive, and slowly it will go, I would say, anywhere in technology. So people do system engineering sometimes without calling it system engineering, but they do it anyways. So now it's getting to a stage where people realize the value of that, not just large organization. There is a misconception that system engineering can only be applied to large projects. Now people start to realize it's also useful for small projects, and they start to realize it's really something useful in many disciplines, not just space or aeronautics or energy. I started as a student at the University of Rome, La Sapienza. I'm originally from Italy, from Rome. And then I moved, done some internships here and there, mostly in the European ecosystem, European Space Agency and so forth. And then moved to the United States, to MIT, Massachusetts Institute of Technology, for my doctorate. And there I had the chance to work in the Department of Aeronautics and Astronautics, worked in projects for in human exploration for NASA headquarters, worked in a project on oil and gas with BP, worked in planetary exploration with JPL, spent some time at Jet Propulsion Lab. And then after this period, looking for a job, right, after PhD, had several offers. I could, stay in the US if I wanted to, but not in space, unfortunately. I could move to Europe in the space field. That was my initial choice. I wanted to work for a research laboratory in Europe, which they hired me. And then suddenly I got this offer to be a faculty in this new university in Russia. And I said, well, you're young, better do it now, right? So I decided to go to Russia. Technology is getting more and more complicated, and more the influence of, let's say, societal influence and political influence is getting more and more relevant for these systems. So I would say that complexity is really what drives us to system engineering. The other thing that I see that is happening is that today the development times for projects is shrinking, especially projects that want to have commercial impact on the free market, right? Of course, if you're working on a science mission, you have 20 years to develop your mission, right? But if you think, for example, I don't know, how often you change your mobile phone, happens in 2 years. Mobile phone is extremely complicated, and you have to get it off the market, continuously, innovation after innovation, very quickly. I think we can divide this in two, right? So there is what is the reason? The reason is market, right? So there is always this push to be competitive, to be ahead of your competition, especially in I'm thinking of systems that are designed for the retail market, right? Consumer products, right? But this is also true for technology, hard drives, memory. Imagine how many times your memory storage changed in the last 20 years, and how is it possible? But first of all, we're developing good system engineering methods to distribute the work among people and make sure that things are coherent. And also, more and more our support tools are getting better and better, right? So this is why it's possible. I think it's really super relevant. Why? Well, innovation means you have to translate an idea that comes from science, that comes from technology, translate it into some viable product that has success in the market, right? So this goes beyond the traditional grant system where you only live of, let's say, federal money or government money, but you really live off the market, and the market decides whether you're going to live or you're going to die, right? So system engineering and system architecture in general are so the message behind those disciplines is that you have to have a very broad analysis, not just focused on engineering, right? So if you use the traditional engineering mindset, there is a high chance you're going to fail because you don't think of all the other aspects that are equally important. So what engineers typically think as soft skills, the economics, right, the sustainability, but not just that, also how you're going to support your system 10 years from now when it's operational. Not just from a technical point of view, but also from a societal point of view, from a political point of view. Is your system robust to policy changes, right? Things like this. So if you do a good job at the system architecture level, you have much more chances that your system is going to survive the market and thrive in there. Technology is the new economy, if you wish, right? So if you think at how our society developed, We started from primary needs, right? Food, agriculture, right? This was the so-called primary sector, right? Then we moved to industry, so building things, with factories, right, in cities. Then we moved to an economy of services, right? And I think that now, I personally think of technology as a fourth sector, right? It's a sector that is not a sector per se, because actually it has an impact on agriculture, it has an impact on industry, it has an impact on services, but it's like a fourth sector that permeates all the production of society, right? So it's extremely relevant. Well, I will share with you a thought that I had the other day. I was visiting a museum in Moscow so it's a Jewish museum about, Tolerance Center it's called. And, there was this beautiful video where they said, some people in Russia, rural Russia, they didn't believe that, that Jews were going to be killed, right? Just they didn't know. Now, I had this thought, I said, look, if 50 years ago we had Facebook, Twitter, social networks, information would flow much rapidly, people would be much more aware of what's happening right now, right? And probably, such strategies could have been minimized or avoided at all, right? Much of many tragedies happened because of lack of information, right, or lack of education. Another really, I think, an interesting thing of technology is the democratization of education. Today, you can have a quality education anywhere in the globe with very little infrastructure. You just need some internet connection and a cheap laptop, and you can access quality education courses from best places in the world. Harvard, MIT, with those free, Coursera, edX, Russia X is going to be. It's just amazing to me. I don't like, personally, to have the application of technology military, because unfortunately technology, improves some military applications. Of course, some people are going to say military is defense, right? But to me it's a fallacious argument, right? So I'm afraid of that. I'm afraid of the use of technology in military applications, and I'm afraid. I still have to decide if I'm afraid of not. There was a recent interview to Elon Musk, the SpaceX founder. He made a comment about that we have to be careful of the advances of artificial intelligence, right? Because now this is getting more and more important, right? I don't fully embrace that worry, but I start to think about it. Should I worry or not? I don't know yet. Yes, I think civilization is great. There are so many good people doing good things around the world, and that makes for all the bad people, right? Right now in the world we have been through this economic crisis everywhere, right? But I think that this cannot last forever, first. There are political tensions every day, one way or the other, but at some point they will fade out, right? So. I'm optimist. I think it's a society that at some point will evolve and will do better and better. It's really curiosity, right? And the excitement of getting new results that can have an impact on people's life, maybe in an indirect way. But definitely, at the end of the day, it's about improving society. So that's great. I see value in my work. This is the same advice that I give to my students at Skoltech, is to do what they are passionate about and what they like. If it's in technology, the better. And eventually, if you do what you like, and you really put all your efforts and energy into that, right? In a sense, you're obsessed by that, right? Eventually, you're gonna do something good for society. You have such a tremendous energy that you have and create with your work that you can direct towards solving, the big issues of society as of today. The energy problem, the improving information, education, whatever that is that drives you. I think this is the best thing you can do for your country, right? For young Bulgarian students, my advice would be, well, first try to improve your own country, right? Go abroad to learn. But never forget about your country, right? At some point of your life, I would advise to, remember where you come from and try to apply what you learn inside your country. It's good, people sometimes say, for example, in my country, in Italy, there is the problem of brain drain, right? So people go away. To me, that's not the problem. To me, the problem is the no return, right? So to go out is great, and I would encourage all young students to go out, right? See the world. But at some point, you can also give back, not necessarily by going back physically, but also doing stuff that is connected to where you come from. This is my advice.